Hello and welcome to Lesson 2-3 on the factored form of a quadratic function. We're going to start right off with example 1 where we're factoring a trinomial. Okay, a trinomial is an expression with 3 terms. And if you remember from what you've learned in the past about factoring, we're looking for factors of 12 that will add up to 7. So I can split this into 2 binomials, right, starting with x and x to give me the x squared, and then it will be plus 3 and plus 4. The inners give me the 3x, the outers give me 4x, and that'll give me the 7x in the middle when I add them together. So remember, all factoring problems you can always redistribute to check all of your terms, right? X times x is x squared. The 3 times the 4 gives us the 12. Okay, so this expression, notice here the coefficient of x squared is a 2. So this makes it a little more complicated, but there's a nice method to this. If you multiply the constant of x, or the coefficient of x squared with the constant, that gives us -6. And then what we do is break -6 down into factors that will add up to -5. And I'm going to rewrite this expression using those factors. So it's going to be -6 and a positive 1. So I'm going to rewrite that middle term as -6x plus x, right? That's from the 1. I don't put a 1x here, just an x, minus 3. So again, all I've done now is I rewrote the -5x as -6x plus x. And now we can use grouping to do the factoring. And that's why we reviewed grouping, okay, in the previous lesson. So if I group the first 2 terms, my GCF is 2x. That leaves me with x from the first term and -3. Now notice I have the same thing here, but I still need to factor out something, right? So what I can do is factor out a 1. And I'm actually going to put that here as a reminder, because remember, eventually that will be getting grouped with the 2x. So if I factor out a 1, that gives me an x minus 3, which remember these two quantities always have to be the same. And then when we pull this out, we're left with the 2x plus 1. So that's one quantity, and the other quantity is x minus 3. And remember, this order doesn't matter. You could write x minus 3 and then the 2x plus 1. And again, all of these can be checked by multiplying, doing your FOIL, multiply all of the terms, and you should go back to the original expression. Okay, example 2. So the graph shows the function defined by y equal to x squared plus 2x minus 8. How do the zeros of the function relate to the factors of the expression? So here the zeros are given, right? -4 and +2. Well, if I factor this, I'm looking for factors of 8, or -8 rather, that will add up to a +2. So that's going to, excuse me, that's going to be +4 and -2, right? They multiply to -8 and they add up to +2. So my factoring will be x plus 4 and x minus 2. So notice the solutions, or the zeros, or the x-intercepts, right? Lots of different names for the same things. These values are the opposite of what we see in the parentheses. And the reason for that, it's related to what we call the zero product property. This is a very important property that allows us to solve for the zeros, or the x-intercepts, okay, or the solutions of the equation. Again, 3 different names for the same thing. The zero product property states that if a product of real number factors is 0, then at least one of the factors must be 0. And that is key, right? This is a zero product property, not any other number. So if I have a times b equal to 0, then either a equals 0 or b equals 0. So going back to our last problem, when I broke those factors into x plus 4 and x minus 2, if I set that product equal to 0, then either x plus 4 equals 0 or x minus 2 equals 0. And then when I solve, I get the opposite. And negative 4 and positive 2, if we go back once again, excuse me, those are the values that we get, right? A negative 4 and a positive 2. Okay, so example 3, now we are solving the equation. So always pay attention to your instructions, right? Solve the equation, let me back up again, versus factoring. If you're factoring, you just factor and you stop there. If you're asked to solve, then we actually want to get what does x equal, right? And we're going to use that zero product property. So when I have a quadratic, the first thing I want to do is always get all of my terms to one side. So I'm going to subtract the 42 and set this equal to 0. Now I can factor, so I want factors of 42 that are going to add up to 1. So that's going to be 6 and 7. So it's going to be a positive 7 and a negative 6. When I set each of these factors equal to 0, then I'm going to get the opposite of those, what the signs that we see within the factors, right? A negative 7 and a positive 6, those are the two solutions of that equation. There's two solutions because it's quadratic. And again, these could be checked. If you plug in, if I get negative 7 and I square it, and then subtract 7, does that equal 42? And yes, it does, because negative, any number squared is positive. So 49 minus 7, that does equal 42. I can check with the value of 6. If I plug in 6, I get 6 squared plus 6. Does that equal 42? Well, this is 36 plus 6, and yes, it does equal 42. So all of these problems that we're doing lately can be checked in one way or another. Your factoring can be checked by remultiplying. Your solutions, when you're solving, can be checked by plugging in. Okay, let's try letter B. So again, move all terms to one side. And then set it equal to 0, right? Because there's nothing left on this side. We added the 9x, we subtracted the 5. Now I'm going to use our other technique where I multiply the 2 and negative 5. That gives me negative 10. And then I'm going to rewrite the middle term. For negative 10, I'm going to use 10 and 1. So I want a plus 10x and a minus 1x. But again, I just write minus x and then minus 5. Group the first two terms. I'm going to take out a 2x. So that gives me x plus 5. And then here I have minus x minus 5, so I'm going to pull out a negative 1 this time. And that will change the signs to both positive. And that's what I need, right? Because again, I want these always to be the same. Okay, so if I separate the two factors, remember the 2x and the minus 1, they go together. And then the other factor is the x plus 5. When I set each factor equal to 0, And eventually we'll be skipping this step and going right to the solutions. But here, notice you're adding the 1, so again it becomes positive, and then we're dividing by 2, so x is equal to a half. Right, so we move the constant, divide by the coefficient. Okay, so from the factor that had a minus symbol, okay, or a subtraction symbol between the terms, gave us a positive solution. The one that has an addition symbol is going to give us a negative solution. And again, I can check these by plugging in. Right? If I plug in a half, I'd have 2 times a half squared plus 9 times a half minus 5. Does that equal 0? Right? A half squared is a quarter, times 2 is 2/4 or a half. 9 times a half is 9 halves. 1/2 plus 9 halves, that's 10 halves. 10 over 2 is 5, minus 5 does equal 0. If I plug in the 5, I get 2 times 5 squared plus 9. Oh, sorry, that's a negative 5. 9 times negative 5, and then minus 5. Does that equal 0? So any number squared is positive, so that's a positive 25 times 2, so that's 50. And then 9 times negative 5 is negative 45 minus 5, and that does equal 0. Okay, so you can always check your solutions by plugging back in. And notice I plugged into this. You could have plugged into the original and compared 2x squared to negative 9x plus 5 and checked it that way as well. Okay, either of these equations are okay to plug into. So that's where we're going to stop for today. We'll pick up with example 4 for the next lesson. Okay, so I hope you enjoyed it and have a good day.